What you're looking at is the fetal heart. It looks a lot like the adult heart, but a couple of interesting differences that we're going to go over. The first thing I want you to notice is that it's mostly got what I've drawn as kind of this purplish blood. You know, in the adult heart, we know there's a real clear distinction between oxygenated blood and deoxygenated blood. But in the fetal heart, it's all very, very similar. Now let's start by kind of orienting ourselves. This vessel at the top is different, right? It's got blue blood rather than this kind of purplish blood. And the reason for that is that this blood is actually coming back from the body, and the body has used up as much oxygen as it can. So this is the superior vena cava dragging blood back from the arms and specifically the head region. And you've also got on the bottom blood coming into the heart from the inferior vena cava. Now this is also coming from the body, but I've drawn it more pink. So why would I do that? Well, it's because you remember there's also, in addition to just bringing blood from the body, there's also blood coming from the umbilical vein. And I don't want you to forget that, because the umbilical vein is actually bringing really, really oxygen-rich blood from the placenta, and it's mixing with the inferior vena cava. So it's not bright red, but it's got this kind of pinkish tone to it, and this is really the only major source of oxygen that the fetus is getting, is from this umbilical vein. So this is actually very, very important. And that's why when it mixes with that blue blood from the superior vena cava in the right atrium, we get kind of this purplish stuff. And of course, let me just quickly label the rest of the chambers. We've got the right ventricle, the left atrium, and the left ventricle. And these are the four chambers, right? Let me also name the major arteries and veins. This, of course, is the aorta at the top. I've also got the pulmonary artery here, pulmonary artery, and we've got pulmonary veins. And I'm just going to label this side right here, pulmonary veins. But you can see there are two on the other side as well. So this is what the fetal heart looks like. And now let's actually think about what's going on in the fetal heart and how the blood is flowing through. So to do that, let me actually start out by drawing some lungs, because this is actually going to help inform the path of blood. So these are the lungs. This is, let's say this is the right lung. And of course there's one on the left as well. Let me just draw it in just so we don't forget that it exists. But I'm going to use the right lung for this example. This is our left lung. I even drew the little cardiac notch. And on the right lung, blood is coming in from, let's say, the pulmonary artery, right? So blood is coming in this way from the pulmonary artery. It's going to go into little vessels, little arterioles. I'll draw them kind of the same purplish color. It's going to go into little arterioles, and then it's going to get into little capillaries, right? Even tinier little blood vessels. And those capillaries are going to go and meet up with an alveolar sac. And these sacs in adults are full of air. But in the fetus, there's actually nothing but fluid inside of here. So it's actually just full of amniotic fluid. So it's just fluid filled. And so if you're thinking about it, do you expect the oxygen level to be high or low? Well, if it's full of fluid, amniotic fluid, it's going to be pretty low. There's not much oxygen there. In fact, blood isn't even going to the lungs to get oxygen, because we said that the main source of oxygen for the fetus is going to be from the umbilical vein. This is where the vast majority of oxygen is coming from. So what ends up happening is that because there's such low oxygen in the alveolar sacs, they have this process, this ability to actually cause the arterioles to constrict. So these arterioles have some smooth muscle on them, and they actually, the alveolar sacs, because of the low oxygen, they make this constrict. So it literally kind of clamps down, and it looks a little tighter, something like this, a skinnier blood vessel. And when it constricts, when you have a smaller radius on that blood vessel, what does that mean exactly? Well, it means that the amount of resistance went up here. And of course, if it happens once, that's not a big deal. But if it happens in millions and millions of arterioles all throughout the lungs, then what we're really talking about is that the pulmonary artery, both of them on both sides, are going to face really high resistance. And this process of kind of increasing the resistance when the amount of oxygen is low Remember, we actually named this process. This process is called hypoxic, and that just means low oxygen. Pulmonary, referring to the lungs. Hypoxic pulmonary. Vaso, meaning blood vessel. Constriction, so making the blood vessels tight. So this is the process that we're talking about, hypoxic pulmonary vasoconstriction. And it happens in adults, but it also happens in the fetus, and it's actually very important in the fetus because the lungs, both the left and right, are full of fluid. It allows the blood vessels to constrict. I say allows, but it causes, let's say, the blood vessels to constrict, and it really raises the amount of resistance that the pulmonary arteries are facing. Now, if they're facing a lot of resistance, think about what that means. That means that if the heart wants to pump blood to the lungs, it's going to have to raise the pressure. So the pressure goes up in the pulmonary artery. And if the pressure is high there, that means the pressure is going to be high in the right ventricle. And if the pressure is high in the right ventricle, blood has to get in there somehow, so the pressures start going up in the right atrium. So pressures start going up everywhere. And so really what the heart faces is a choice. It can either continue to just try to push blood into the lungs, even though there's a lot of resistance, or it can try to find a shortcut, really to bypass the lungs altogether. And that idea of shortcuts is really what we're talking about in the fetal heart. In fact, there are two. There are two shortcuts to get blood from this side, the right side, either the right atrium or the right ventricle or the pulmonary artery, over to the left side. And when I say left side, I really mean, at the end of the day, the aorta, or I guess you could think of the left atrium or left ventricle as well. But really, at the end of the day, you want to get blood into the aorta, right? And you want to think of a clever way of doing it and being able to bypass the lungs. That's the challenge. So how does the fetal heart meet that challenge? How does it bypass the lungs? Two major ways. So let me draw them both out. I'm going to start with drawing kind of a blow up of this section right here. Let's say I blow that up, and I'm going to try to sketch it out here for you. Let's see if I can make it neat. This is kind of the same box, right? So just want to make sure we're not confused by the way I'm drawing it. This is just a blow up of that section. And if you looked closely, what you would see is that there's a wall, right? Just same wall that I drew. But there's actually not just one wall, it's two walls stuck together. That's actually kind of the first point I want to make, is that there's not just one, but two walls there. And this one is called septum primum. Septum just kind of refers to a wall, and primum is the Latin word for first. And so septum primum is this wall over here on this side, this guy. And septum secundum is the other wall. So you've got two walls next to each other, and they look almost like one wall, right? But there's actually two, and that's the septum secundum. And just to make sure we're still kind of oriented to the right and left atrium, on this side is the right atrium, and on this side is the left atrium. And remember, the kind of overall goal is to somehow bypass the lungs. And what I mean is get blood from here somehow over to the other side. And what happens is that when you look closely at the septum secundum, if you look closely at that one, there's a little tiny hole there. So a little bit like imagine a piece of Swiss cheese. And if I was looking at this wall as if it's a piece of Swiss cheese, the hole actually is in the wall. So there's a little hole there. And so if I kind of stuck my finger in here, let's say I stuck my finger right here, I would actually be able to touch, from the right atrium, I could actually touch the septum primum because of the fact that there's a hole in the wall. And so this hole, let me take my finger out of here now, this hole is called the foramen ovale. Let me actually just label that for you, or foramen ovale. So the foramen ovale is this hole. So instead of calling it hole, you can now call it by its full name. And this foramen ovale is right there. Now it turns out the septum primum also is kind of like a piece of Swiss cheese. Both of them are like little pieces of Swiss cheese, and it's got a little break in its wall as well. So now think about it. What will happen if the pressure is really high in the right atrium? Pressures are really high on this side. And of course, pressure is kind of force pushing out on the area, the surface area of the chamber. So blood is kind of pushing in all directions. And when it pushes here, right in the foramen ovale, what's going to happen? Well, right at that spot, if there's pressure, then this septum primum does an interesting thing. It becomes a little bit like a flap or a valve, and it kind of falls away. It falls away like that. And so, bingo, you've got access, right? Right atrium blood is going to flow right into the left atrium because the septum primum became a little flap and it fell away. So let me actually now re-sketch this out in the middle drawing and make it the way it should be drawn. So instead of drawing it like that, you've got literally a little flap here. This is the septum primum flap of tissue. And you've got, here I'm drawing the septum secundum, right? And I'm going to draw blood now going through. So you've got blood kind of flowing through, and let me make sure I got this right, and right there. So blood is now going to go through from here into the left atrium. And remember, this little hole, I can't draw a hole very easily, but you can imagine that there's a hole there. In the wall of the septum secundum, where the blood is going through, that hole is called the foramen ovale. And so this is kind of, when I said there are a couple of tricks, this is trick number one. Trick number one is getting blood from the right atrium directly over to the left atrium. Because you know that once it gets over there, now it just literally has bypassed the lungs. But that's only one of two tricks. So not all of the blood in the right atrium goes through the foramen ovale. Not all of it. Some blood actually passes through the normal way. It goes through the tricuspid valve into the right ventricle. And if blood is going to the right ventricle, that is a good thing. Why? Because we want to make sure our right ventricle is pumping. We want to make sure that it's squeezing, getting practice, and that those muscles are getting stronger. Now, the right ventricle is going to do its job. It's going to pump blood into the pulmonary arteries, the left and right pulmonary arteries. And that blood is facing, as I said before, a lot of resistance, right? So there's another little trick. It turns out that there's another place for the blood to go. You're looking at this picture, you're thinking, well, I don't see any other place for blood to go. There's only the left artery, the left pulmonary artery, and the right pulmonary artery. But there is another place. Turns out that the fetal heart actually has a little vessel here. I'm going to do the vessel in another color. So it has a little vessel here, and this vessel allows blood to go through. So you can actually get blood to pass through this vessel like so. So this is actually really cool, right? Because you can now see how blood can go directly from the pulmonary artery into the aorta and go down. This is our trick number two. And so this little vessel, this little guy right here, I'm going to loop it and name it. This is our ductus arteriosus. Now, remember there's another one called the ductus venosus. So this is ductus arteriosus. So different name. But this is trick number two. So one trick was to go from the right atrium to the left atrium, and another trick was to go from the pulmonary arteries to the aorta. So these are the two major tricks, and you basically can see now that blood is going to bypass the lungs using either trick. Now, does that mean that no blood goes to the lungs? No. A little bit of blood does go to the lungs. In fact, about 10% or so continues to the lungs. But 90% actually goes through one of these two pathways, either through the ductus or through the foramen ovale. So these are the kind of interesting differences between the fetal heart and the adult heart.